Today we're doing a chicken wing dissection lab, and I'm just going to run you through the very brief steps before you head into the lab. So if you have a book or a notepad, I would suggest just writing down some key steps so that you know what to do next and you don't miss anything. So before we even pick up a tool, it's important to make sure that you are totally ready. So you've got your sleeves rolled up if you've got long sleeves, you've got your hair back, you've got goggles on just to protect your eyes in case you have the temptation to touch your eyes. You don't want to spread salmonella and give anyone salmonellosis today. That would not be great. So making sure the only thing that touches chicken is your hands, so that when you clean your hands, everything is hygienic. Alright, so in front of me I've got a chicken wing, I've got a scalpel, some scissors and some tweezers. You may have one or all of these things. It's important to have something sharp. Scissors are actually really useful, and tweezers can just help pull and stretch things apart as you go, if you do have that. Some people think this lab is boring because it's just a chicken wing and we've all worked with chicken at home, but I think it's really amazing once you recognize that the chicken wing and the human arm are what we call homologs. That means that they evolved from a common ancestor that had the same structures. So actually the muscles, the bones, the joints, the tendons, the ligaments in a chicken bone are a tiny version of your own arm. And once you think of it that way, it's pretty interesting. Up here I've got the shoulder joint. Okay, so this would attach to the actual torso of the chicken. And then I've got the bicep and tricep, okay, and that powers this forearm here. And I've got two bones in there. If you actually feel your arm, you'll notice you've got the same two bones there, the radius and the ulna. Okay, and this is your humerus up here, or the bone underneath your bicep and tricep. Okay, so two bones in there. You might recognize them from eating chicken wings. This is my wrist, okay, the wrist bone. And then unlike humans who benefit from having a pentadactyl or 5-digit hand, chickens have evolved for all of those bones to be stuck together. So they've got the same bones, but they've fused over time because this provides an advantage to the bird in terms of flying. You can see here, this is called the ulula, and this is the bird's thumb. It's got a little claw on it. And this is used for primarily defense. So they've still got that thumb, and then the rest of their digits have fused together, and that's in there. All right, so the first thing you're going to want to do once you've had a look at the chicken wing in its entirety is to remove the skin. This is a really tricky and long, arduous task because you don't want to nick the muscle. And the muscle is the part you think of as the meat. So make sure when you're removing this top layer of skin, which is kind of adhered to the muscle with connective tissue, you want to be very careful that you don't nick the muscle. And actually the easiest way to do this is just like I'm doing it here, with your own fingers, really getting in there and pulling it off. That's the easiest way. Once you pick up scissors or a scalpel, you're at risk of ripping that muscle. So I'm going to pause here and take my time to remove all of the skin, so I'm left with the meat only. Just before I start, I found a way in with my finger here in this piece of skin. If you can't find a way in that's easy, the best part to start with is this webbed piece of skin here. If you snip in there with your scissors, you'll be able to pull it apart and start pulling it off. If you're really struggling, just try and get the skin off this underside, this side of the arm, and you can leave the skin on that side. So as you're removing the skin, you're going to find that it's really greasy, and this is due to the fat, the adipose tissue under the skin. So best thing to do is just take a hand towel and dab away as you go, just to really dry off the meat, so that it's easier to work. Okay, so now I've removed a lot of the skin, and I can look around at kind of the structure of the muscles and see if I can identify the similarities between this chicken's arm and my arm. Up here, the bone inside here would be your upper arm, your humerus bone, and then you've got on the front of that your bicep. Bi being two, so you can see two distinct muscle groups there, creating the bicep, and then on the back you've got the tricep, tri being 3. Here, this would be the elbow joint. This here is the equivalent of the wrist joint. What we can do now is bend and extend these muscle pairs. We know that muscles move in pairs. They cannot actively stretch, so we can contract the muscles, and then in order to move the joint in the opposite direction, you have to contract the antagonistic partner of that muscle. So you can play around with this, either holding the bicep and tricep or the muscles around the forearm, and if you squeeze and pull these in opposite directions, you'll recognize that you're pulling on opposite bones. We know that muscles, they attach to one bone and then move across the joint to attach to what we call an insertion point, which is the bone that is going to pull towards the origin. So by pulling on these muscles, you can see them pulling muscles on the other side of a joint, and you can stretch and bend as you go. So have a little play around with that. It's easiest to use these forearm options because you've got 2 insertion points to play with. You can try and move the forearm using the bicep and tricep. It's a little bit more difficult, but still a bit of fun. So this muscle here attaching to the humerus bone and then across the joint to this bone down here, the radius or the ulna, which one I can't identify yet. We can identify tendons as pieces of shiny white connective tissue that are attached to a bone on one end and then muscle on the other. So this is what we're looking for here. This is a tendon. Okay, and I'm going to try and identify as many as I can. There's another one there. Let's have a look on the back. Yep, so shiny white connective tissue attaching on one end to bone and one end to muscle. Side. Okay, so we can see a tendon just here. Okay, it's connecting a bone here and this muscle right here. So it's going to pull, when that muscle contracts, it's going to be able to move those bones. We can see some blood vessels here, skinny little red tracks. You can actually move the blood along as well if you push with your fingers. And often running along next to the blood vessels are nerves, and they're just tiny little white strings. There's these long stringy things. There's one here and there's one here that are more of a yellow-pink, and they can be separated from tendons or other forms of connected tissue by their colour, and that there would be a nerve. Now if you pull on a nerve, you'll notice that it can move other parts of the wing, and this, it's hard to get because it's so greasy. This nerve is connected to the wing tip and it comes all the way down to its origin over here. And the reason we need nerves is because this type of muscle is what we call skeletal muscle. It is a voluntary muscle, which means that the instructions for moving that muscle come from your brain, and those action potentials or impulses that tell the wing to flap, they need to come from the brain and travel down the wing and tell it where and how to move and how strongly. So you've got the nerves there. We also want to try and look for blood vessels, and there's a lot of blood vessels in muscle because they are such energy hungry tissue. They need lots of oxygen to make energy, and they need to remove lots of waste because they're respiring constantly for movement. It's hard to use meat that has been drained of blood to try and find a blood vessel, but if you look carefully as you're dissecting, you will see certain vessels that you can tell have blood inside of them, and there's your blood vessels there. Sometimes they run parallel to nerves and they can be seen that way, and they're quite delicate, so they will fall apart. So you can see some more blood down there from a blood vessel that's burst. So if you can try and identify those two stringy structures, that would be awesome, but it can be very difficult. So now I'm going to go ahead and try and take off as much meat as possible, all of those tendons, so that I'm left just with the bones and the tissue holding those bones together. Alright, so it takes a little bit of time to remove the muscle without damaging any of the ligaments underneath, but I have managed to get quite a good look at a ligament. Now what we're looking for there is at a joint, shiny white connective tissue not dissimilar to the tendons that we've already looked at. However, in this case, the tissue is extending from bone to bone across a joint, making sure that those two bones at a joint stay kind of in the vicinity of each other while they're moving, so keeping them stuck together. Now what I've looked at here is in my elbow joint, I've removed as much muscle as possible, and you can see this piece of tissue here extending, stuck to this bone here, and it's stuck to this one here, meaning that as these bones move in their synovial joint, they stay stuck together, and there would be one on the other side as well, if I could get through all of that tissue. But try and get the best you can. Oh, there's one, you can see it slightly extending from this bone across here. And you'll see them at all of your joints if you can get in there. So if you can't find them at one joint, try another. Here's another one here, quite an obvious one extending from this bone in the hand over to the wrist. So that would be like these tendons that we see here in the human hand, yeah, where you have your carpal tunnel in there. So what we can do now is you want to pop a joint. Try not to think about it. It's a bit gross. What you want to do is have a look at the end of a bone. If I can get them apart. Be careful that you don't hurt yourself. Okay, and we want to have a look at the end of a bone so that we can feel and identify that cartilage, that cap on the top of the bone that stops these two bones at a joint from having too much friction that stops them moving and causes pain. So they're nice and slippery and slidey so that they don't hurt when you move your joint. And you'll notice that they're at the ends of the bones, these kind of gristly cartilage caps, rather than in the middle where there isn't as much friction. So once you've done that, you're going to want to look inside a bone, and I suggest you look at the radius, which is the bone that is in your lower arm on the thumb side. So we're going to snap that bone if you can remove it from the rest. You should be able to do that with your hands. And you can have a look inside a bone, and you'll see, if I remove some of this tissue, you'll see in the bone this red stuff. It's really gooey red stuff, and that is bone marrow. That is the amazing tissue inside your bones that creates your red and white blood cells and your platelets, and that is to keep your blood really healthy and doing its job, carrying oxygen and other dissolved nutrients and waste in and around your body, as well as creating the platelets which produce scabs so that you don't bleed everywhere when you hurt yourself. So yeah, all of those blood cells are super important, and they're made here in this marrow, and that's the last thing. You can try and dig it out if you want with your tweezers or the edge of your scissors if you want to get a little bit out. And yeah, that is the chicken wing dissection.